It wasn't like a normal NASA press conference. Usually at such events, you get a rocket, a number, a slide, maybe a graphic that nobody will remember in 5 years. Then, the journalists are allowed to ask a few questions which are either not answered or only partially answered, and then everyone goes home. This was completely different. On March 24, 2026, NASA presented 5 fundamental strategic decisions at a single event they called Ignition. A new Artemis architecture, a detailed 3-phase plan for a permanent lunar base, a strategy for the ISS Successor, and a science initiative that was truly impressive. And the most exciting of all, a mission that hardly anyone is talking about, even though it may be the most important space mission of the decade. That wasn't a press appearance. That was a program. My name is Serwin, and this is Mars Chronicles. To understand why this day is historic, you have to take a quick look back. Not far, just a few months. In February 2026, Jared Isaacman, the new NASA administrator, publicly restructured the Artemis architecture. Higher cadence, less complexity, and the Gateway space station in lunar orbit effectively cancelled. I covered that in detail in a separate video. You'll find the link below, of course. What was missing back then? The big picture. The answer to the question, okay, but where is all this leading? Ignition is the answer. Let's start with what deserves the most attention. The Moonbase. Because for the first time in history, NASA has not only announced a lunar station, they have presented a concrete, detailed plan with a timeline and budget framework outlining how this base is to be built step by step. Not as a concept study, but as a construction program. The plan is called Moonbase and it has 3 phases. The first phase is already underway. It didn't start with Ignition, but technically with the first successful CLPS lander, Firefly Aerospace Blue Ghost Mission 1, which brought 10 NASA instruments to the lunar surface in 2025. But with Ignition, NASA has drastically increased the pace and given the CLPS program much greater significance. The goal of the first phase, which runs until 2028, is radically ambitious. Up to 25 missions, 21 of them landings. No manned missions, but commercial CLPS landers that bring equipment, instruments, and infrastructure to the base. In addition, there will be communication satellites in lunar orbit to ensure a permanent connection between the South Pole and Earth, and something that I thought was a typo when I first read it. Moon drones. They're called Moonfall. We're talking about small propulsive hoppers, so not helicopters, because as you probably know, the moon has no atmosphere. They'll be rocket-powered hopping devices that can overcome and map difficult terrain, up to 50 kilometers range per mission. This isn't a toy, it's a tool. For this first phase, NASA is investing $10 billion. The budget is set. The schedule is fixed. And the first robotic landings, as Isaacman explicitly said, will begin later this year and in early 2027. The moon base won't start in 2035, it's already under construction. But what exactly is being built there? This question brings us to phase 2 from 2029 to 2032. This is the early settlement phase. And for that, another $10 billion are allocated. This is where it gets specific. Commercial landers will be upgraded to carry up to 5 tons of payload per mission. A total of 60 tons of cargo are to land on the moon during this phase. 60 tons. For comparison, all the Apollo hardware that landed on the moon weighed significantly less in total. What lands with these 60 tons? Solar panels, the first nuclear power systems, more on that in a moment, and improved second-generation rovers. Habitats for the first permanent human presence and communication towers that ensure a stable connection between the surface, orbit, and Earth. And then there's JAXA. Japan is providing the Lunar Cruiser, a pressurized rover that can accommodate 2 astronauts for up to 30 days. Not in space suits, but inside the rover. It's basically a mobile habitat. The rover can travel a bit faster than walking speed, but on the moon that's more than enough. Without paved roads, you probably wouldn't want to drive any faster anyway. This is the moon's RV, and it gives astronauts a range of several hundred kilometers from their base. Phase 3 begins in 2032 and goes beyond that. This is the phase when the moon stops being a project and becomes a place. In this phase as well, NASA is planning a budget of $10 billion US. Permanent habitats with real living space for a rotating crew. A fully operational nuclear reactor that gets the base through the 14-day lunar night, and a sophisticated logistics network of manned and autonomous rovers. And the beginning of ISRU, that is in-situ resource utilization. Astronauts or machines extract oxygen and hydrogen from the lunar regolith, producing water and fuel directly on site. From Phase 3 onwards, up to 38 tons of cargo per year are supposed to land on the moon. And NASA makes it unmistakably clear where this is leading in the long term. The moon is not the goal. The moon is the starting point for asteroids, Mars, and the outer solar system. Now I have to briefly talk about something that must not be forgotten despite all the excitement. The first phase cost $10 billion, phase 2 another $10 billion, phase 3 at least $10 billion. NASA itself has strongly emphasized that at least part. Altogether, we're talking about $30 billion just for the Moonbase by 2036. The math geniuses among you have already estimated that this means about $3 billion US per year. That sounds like a lot, but it's not even an eighth of NASA's current budget. NASA, like so many other institutions and even entire countries, doesn't have a budget problem, but a spending problem. If the funds are used properly, NASA has more than enough funding for such adventures. But when officials throw taxpayers' money around and constantly demand more funds, we're not heading to the moon anymore, but straight into a deep hole. However, that only works with leadership that has backbone and isn't contaminated by the murky world of career politics. Instead of just blindly demanding more money, the new NASA chief, Jared Isaacman, has set out to hold the tens of thousands of NASA employees and contractors accountable. Not only does NASA not need any additional money now, but they're also accomplishing much more with the same budget that was full of holes last year because other leaders couldn't manage the money. The billions just mentioned are only a part of the total budget. Artemis is running in parallel. Space Reactor 1 is running in parallel. The ISS Successor is running in parallel, and the science missions are also running in parallel. A lot of money is saved by primarily standardizing the SLS rocket and no longer letting Boeing, Lockheed Martin, and Northrop Grumman lead NASA around by the nose. Here you can see the value of a NASA chief who actually knows about spaceflight and doesn't just shake hands and suck up to senators and members of Congress. His expertise managed to convince even Congress that the changes make sense. Furthermore, the Gateway space station in lunar orbit will be cancelled. The resources intended for it will be invested in the lunar base on the moon's surface. That's the proof that I was right. The station is 100% an end in itself, just to give the ISS oversight bodies something to do. In the new plan, these people will be integrated into the operation of the Moonbase after the station is decommissioned. That has already begun. Carlos Garcia Gallan was previously the deputy program manager for Gateway and is now responsible for building the Moonbase. And not only is NASA not laying anyone off, but they're also actively hiring people again to bring a lot of expertise back into NASA. Some employees were let go because they were originally hired for DEI reasons, which by definition is racist, sexist, and patronizing. But now we come to the part of the ignition event that was almost completely overlooked in public reporting. And wrongly so, because it may be the most significant announcement of the entire day. If you like the topic, feel free to give the video some hype. That's really important so it gets shown to more curious people like you and me. And if you haven't done that yet, feel free to subscribe and consider supporting the channel as a channel member. Our members get to see the finished videos days and sometimes even weeks in advance. Thank you all, and now back to the topic. America is returning to space with nuclear power, and with a mission that has a specific launch date. In December 2028, Space Reactor 1 Freedom is scheduled to launch. This is the first space reactor that America has sent into space since 1965. Since SNAP-10A, the only American space reactor that has ever flown, over 60 years. More than $20 billion in over 12 failed programs. And exactly one successful mission. SAR-1 Freedom will change that. The spacecraft uses nuclear electric propulsion technology. A reactor with over 20 kilowatts of electrical power supplies ion engines that accelerate the vehicle through space continuously and very efficiently. Within 48 hours after launch, the reactor is to be powered up and the engines activated. The goal? Mars. In about a year of travel time. The payload? 3 Ingenuity-class helicopters, part of a mission called Skyfall. These helicopters are to be deployed after arrival in the Martian atmosphere to explore possible landing sites for humans, map subsurface ice, and transmit navigation data for future landers. And then, in 2030, the Lunar Reactor 1 will follow, the first nuclear reactor on the surface of the Moon. Directly informed by the flight data from SR-1 Freedom, why is this so significant? Not because of Mars, not because of the helicopters, but because of a phrase that was in the SR-1 presentation and immediately caught my attention. The presentation described SR-1 Freedom as the first freight run on the transcontinental railroad of the solar system. The first freight transport on the transcontinental railroad of the solar system. Boom! Let that sink in. Or even better, rewind 10 seconds and listen to that again. That's not poetic exaggeration, that's a precise strategic statement. Nuclear power is the only energy technology that works everywhere in the solar system, regardless of distance from the sun, dust, and shadow. It is the foundation without which a permanent human presence beyond Earth's orbit is structurally impossible. Solar energy works on the Moon, but not in the permanently shadowed craters where the water ice is located. Not even when it's dark for 14 days, or on Mars during a dust storm that lasts for weeks. And at Jupiter? There, the solar panels drop to 4% of their output on Earth. 4%. NASA summed it up in one sentence. Nuclear power works in the shadows. It works in dust and it works far away from the sun. But before we continue, we need to pause for a moment. Because there's a question you should ask yourself about everything I've just described. An uncomfortable question that serious journalism must ask. Haven't we heard that before? Big plans, impressive graphics, precise schedules with budget limits, and then 3 years later, a new administrator, a new program, a new graphic. Constellation cancelled. Lunar Gateway de facto cancelled. Commercial crew years too late. SLS Block 1 and Block 2 cancelled. The list is long. So why should it be any different this time? It's a fair and legitimate question, and the answer isn't clear-cut. But there are 3 structural differences compared to all previous programs that I consider relevant. The first difference is that this plan doesn't depend on a single technology. Earlier lunar programs always lost their footing whenever a single system had problems, whether it was SLS, HLS, Gateway, or Orion. The new architecture distributes the load. CLPS landers come from several private providers. The habitats are being developed commercially. The landers for Artemis come from SpaceX and Blue Origin in parallel. If one stumbles, the other keeps going. The second difference is the pressure. Not political, but strategic pressure. China has a concrete timetable for a manned moon base at the South Pole. Chang'e 7 launches this year. Chang'e 8 is coming in 2028. The ELR space is scheduled to be ready in 2035. China doesn't waste time, and they don't turn it into political bickering. These are missions that actually launch. And Isaacman has openly addressed this in his presentations. The geopolitical pressure that the Sputnik shock once placed on Apollo is back again. This time it's quieter, but it's there. The third difference is Isaacman himself. He is neither a politician nor a veteran of bureaucracy. He is a pilot and entrepreneur who has flown into space himself twice. The way he spoke at Ignition was noticeably direct. He publicly said what NASA has done poorly so far. A 3-year launch cadence, an architecture that jumped from Apollo 8 straight to the moon landing without Apollo 9 in between. A program that was more occupied with Congress than with the moon. Of course, that doesn't change NASA's structural problems. Congress controls the budget. Contracts continue. Constituency interests don't disappear just because a new administrator politely points out that they're slowing down the program. But the rhetoric and the architecture behind it are different from anything I've heard from NASA in the last 10 years. Now let's get to a part of the Ignition event that's been widely discussed in the spaceflight community, but has barely reached the general public. The ISS Successor.
We cannot fund a path of 2 stations. It's a challenge to even fund one.
The International Space Station has been running for over 25 years. It has hosted more than 4,000 scientific experiments, visitors from 26 countries, 110 spacewalks, just for repairs and maintenance. It was built and operated at a cost of more than $100 billion, and it's coming to an end. That was known. But what was new with Ignition was the honest analysis of what comes next, or rather, what still hasn't materialized. NASA program manager Dana Weigel put something on the table in her presentation that you rarely hear from an agency, a sober assessment of their own plan. The original plan was for private companies to build commercial space stations, with NASA as one customer among many. Space tourism would flourish, industrial production in microgravity would develop. The market would sustain itself. But what actually happened? After 25 years of commercial operation of the ISS, a self-sustaining market has not developed. No breakthrough product that can only be manufactured in microgravity. No tourism segment that goes beyond occasional sovereign missions. And no independently verifiable data proving that a commercially operated station would be economically viable without NASA as the main customer. This is not an attack on private spaceflight, but rather an assessment. And the consequence is, NASA does not have enough budget for 2 commercial stations. Not even for one. There is a multi-billion-dollar funding gap. And the original approach, just waiting for the market, is not a realistic path, according to NASA itself. So what is the alternative? At Ignition, NASA presented an approach that sounds strange at first, but upon closer inspection has a certain elegance. Instead of building a new station and then simply deorbiting the ISS, which would mean an interruption of operations, a new core module is to be docked directly to the ISS. This module brings its own propulsion, its own power supply, and its own life support system. Then commercial modules will be added, and only when the new infrastructure is fully developed will the ISS be deorbited, and the new modules will separate to become an independent station. No operational downtime, no gap in the American presence in low Earth orbit, and a commercial infrastructure that matures under the protective umbrella of the ISS before it has to stand on its own feet. The available budget is $250 million per year until the end of the ISS. That's not much for what's planned, but it's a start. Now let's talk about science. Because Ignition was not just infrastructure and architecture. Dr. Nicola Fox, Associate Administrator of the Science Mission Directorate, presented a science agenda that is impressive in its breadth. The James Webb Space Telescope continues to deliver images that rewrite textbooks. In February 2026 alone, more than 50 solar flares, including several X-class events, the strongest known occurrences of their kind, were recorded by the Solar Dynamics Observatory. The Nancy Grace Roman Space Telescope is fully assembled and is ahead of schedule and under budget. With a possible launch as early as this fall, NASA has never been able to claim something like that before. NEO-Surveyor, NASA's first space-based planetary defense system, is moving toward a launch in 2027. And then there's Dragonfly, a nuclear-powered rotorcraft mission to Titan's surface. You can also find a video about this in the description below. Titan, Saturn's largest moon, is the only moon in the solar system with a dense atmosphere and liquid lakes on its surface. Not made of water, but of methane. Dragonfly is supposed to land there, fly, take samples, and search for organic molecules that could indicate chemical processes we know from early Earth. The assembly phase began in March. Launch in 2028. And then there's something else that I almost thought was a mistake. Comet 3e Atlas, an interstellar comet that's currently passing through our solar system. Interstellar, meaning it comes from another star system. NASA has activated a coordinated fleet response for this. TESS, Europa Clipper, Parker Solar Probe, Perseverance, James Webb Space Telescope, Hubble, all focused on this object at the same time. This is the first time humanity has observed an interstellar object with such a fleet all at once. By the way, you'll also find a video about that linked below. Thanks to decades of work, NASA was able to respond easily because the infrastructure was already in place. This is NASA that Isaac Mann means when he says faster, farther, first. And now I want to connect the dots, because ignition was not a grab bag of announcements. It was, when you look at it as a whole, a coherent strategic vision. The thread that ties everything together is called cadence. Artemis, from 3 years to 10 months between missions. CLIPS, 30 landings in 3 years. Moonbase, 3-phase construction with a fixed investment commitment per phase. SR 1 Freedom fixed launch window in December 2028, which is non-negotiable because the transfer orbit is non-negotiable. ISS Successor gradual without operational interruption. Faster access to data, more parallel processes, less bureaucracy. Every single one of these decisions follows the same logic. Frequency creates experience. Experience creates reliability. Reliability creates trust. And trust with Congress, with international partners, with commercial actors, is the only currency with which you can sustain a space program in the long term. So what is still missing? What hasn't Ignition delivered? 3 things come to mind. First, a clear budget for the overall program. $30 billion for the Moonbase plus Artemis plus SR1 plus ISS Successor. Those are costs that have never been clearly stated in any official NASA figures. The question of how all this will be financed remained unanswered that day, even though Isaac Mann repeatedly emphasized that the money is already there. It would just get bogged down in bureaucracy and be put into ridiculous programs that only exist to satisfy some politicians. Think Gateway and SLS? Second, the role of SpaceX. Starship is the human landing system for Artemis 4 and probably also 5. Without Starship, there will be no moon landing in 2028. But SpaceX was strangely absent at Ignition. No Starship update, no demonstration of orbital refueling, no public statement about the milestones. That's a vulnerability that NASA doesn't control. Third, China. Isaac Mann hardly addressed China directly at Ignition. He hinted at it, talking about American leadership, about national imperatives, about the urgency of cadence, but direct engagement with the issue? With the question of whether America is moving fast enough with this plan to secure the strategically important South Pole region of the moon before China establishes a permanent infrastructure there, that direct engagement did not take place. That is not a weakness of the plan, but it is definitely a question that hangs over this plan. And it will be answered in the next 2 to 3 years. What will remain at the end of Ignition? A feeling I haven't had in NASA reporting for a long time. The feeling that the people presenting this plan actually believe it will work. Not as a political statement, not as a defense of the budget, but as a real undertaking. Carlos Garcia Galan, you remember, the former Deputy Gateway Program Manager whose program was effectively cancelled, was introduced at Ignition as the new Moonbase program lead. He stepped up to the microphone and said these words, "I'm your Moonbase guy."
Good morning, everybody. I'm Carlos Garcia Galan. I'm your Moonbase guy.
That's not bureaucratic talk, that's someone who has a mission and accepts it. The first robotic moon landing as part of the Moonbase program is scheduled to take place in 2026 or early next year, that is, 2027. The first manned moon landing since Apollo will follow in 2028. 2 moon landings in a single year are the goal for 2028. A nuclear reactor is supposed to be on the moon by 2030. That's the plan. It is ambitious, more expensive than publicly stated, and depends on technical milestones that have not all been achieved yet. And it depends on a Congress that has to be willing to fund it. But according to Isaacman, the necessary members of Congress, international partners, suppliers, and employees are all on board and ready to pull together. But this is the most concrete, honest, and coherent plan NASA has presented since Apollo. And if it works, if the cadence holds, if the technology delivers and the budget flows, then in 10 years we'll look back on the 24th. March 2026 and say, that was the day it began. My name is Serwin and that was Mars Chronicles. Thank you for tuning in. Per aspera ad astra. Specifically with a mission, delicious coffee. Are you not entertained? Are you not entertained? Who understands what I meant by that? I talk so intensely that my beard hairs fall onto my shirt. I love this topic, you can tell. I love it. I think this could turn out well. Yeah. Boom, bam, boom.